Hello, scholars, and welcome to our lesson on categorizing numbers as rational or irrational. Today, we are going to continue on a discussion you've been having for a long time. In elementary school, you started learning about numbers, and you started to get more and more specific into numbers. At first, you learned about numbers that you could count. And then eventually you started learning about negative numbers and fractions. And we are kind of finishing up that conversation to an extent this year. We are going to learn about the real number system, all numbers that are real, that can go on the number line. Next year, you will get into a conversation about imaginary numbers, numbers that do not live on the number line. This year, we are finishing a conversation about what are the numbers that live on the number line and how do we categorize them as rational or irrational numbers. You should have this flipbook made already. Let's open it up. So there are lots of examples of rational numbers. We are going to talk about how we can categorize them more and more specifically. But the big idea is that everything that ends up on this side of our flipbook here is a rational number. Whether it's a natural number, whole number, integer, these are all rational numbers. So let's write a definition. A rational number, a number is rational if it can be written as a ratio of two whole numbers. That is a number over another number. We know this as a fraction. Yes, if it can be written as a fraction, and that is really our best definition for is something rational? Well, can I write it as a fraction? If you can manipulate it in a way to write it as a fraction, it is a ratio. For instance, the number 2 can be written as 2 over 1. That is a fraction, which means it is rational. The word rational, the word ratio, a fraction. I want to write a note. This also includes terminating and repeating decimals. Okay, so let's go on a journey real quick. These, like we already said, are all examples of rational numbers. In the beginning, you were in kindergarten and you learned about natural numbers. Little did you know that that is a rational number. Natural numbers are our counting numbers. They are anything you can count to. 1, 2, 3, 100, 1,000, 1,000,000. Then you started to learn about whole numbers. Whole numbers, the only difference here is it includes the number 0. That is the only number that is rational, there's only one number that is not contained in the natural numbers that is a whole number. It is 0. That means that all natural numbers are also whole numbers, though. That's why this is sitting on top of it. All natural numbers and all whole numbers are integers, and all integers are rational numbers. We need to remember that. So what makes something an integer? Well, it is our positive and negative whole numbers. So all those whole numbers are integers. Also, all of our negative numbers. For instance, -3 is an integer. -12 is an integer. -50 is an integer. Any counting number with a negative sign out front is an integer, and all integers are rational numbers. Now, there are other rational numbers that you've learned about in late elementary, early middle school. Any fraction is rational. It's a ratio. Any decimal that stops. Any negative fraction. Any repeating decimal. 0.3 repeating. Okay? So notice that it doesn't matter if it's negative or positive. An irrational number can be negative. A rational number can be negative. The question is, can it be written as a fraction? Things that can be written as a fraction include terminating and repeating decimals. Okay, now let's go over and define irrational numbers then. An irrational number is shockingly, it cannot be written as a ratio of two whole numbers, or we could just say written as a fraction. But we're specifically defining fraction here to be a ratio of two whole numbers that doesn't contain decimals or square roots or anything like that, okay? Now, this includes non-repeating and non-terminating decimals. A decimal that does not repeat or stop is going to be an irrational number. Two examples of this then. There are infinitely many numbers that are irrational, but there's some specific categories that they fall into. First category, imperfect squares. We didn't put a perfect square over here, right? The square root of 36 is 6. So the square root of 36 is, to get technical, a natural number, right? But perfect squares are rational. Imperfect squares are irrational. Numbers that have decimals that neither repeat nor terminate. For instance, pi. The decimal of pi never stops and it never repeats. It just goes on forever and ever. We could write down other imperfect squares. For instance, negative square root of 7. There's no number times itself that gives us 7. I don't care if the imperfect square is positive or negative. It does not matter. Let's write down one more example. We could write down 6, 1, 3, 8, and if I include a ... here at the end, I am indicating that this is a decimal that does not repeat and it does not terminate. It's just going to go on forever. I don't know how it's going to continue, but it continues to go on and on. Okay, let me know if you have any questions about categorizing numbers, but now it is time for you to practice. Are numbers rational or irrational? You need to be able to categorize them, and I want you to be able to be as specific as possible. Thank you.